Hey guys, Mr. Marone here. Welcome back in. We are in section 6.1, so this is the first time that we move away from triangles and look at other polygons or other closed figures. The one thing that I want to note before we get started is whenever we look through anything with polygons, you're going to see the letter N a lot. And N refers to the number of sides in a given polygon. So that's just something to keep in mind, that when you see N, they're talking about the number of sides. So the way that we really break this all down, the way that we kind of think through polygons and really think about the inside angle measures of a polygon, we use triangles because we know that every triangle equals 180 degrees. So if we look closely at all of these pictures, we can break these into the number of triangles available. So like this quadrilateral can be broken into 2 triangles, and so on and so forth. Pentagon into 3, hexagon into 4, septagon into 5, and it leads us to this whole setup right here, that no matter what number of sides we have, if we subtract 2 from that, that's the number of triangles that we're going to have. So it creates this interior angle sum theorem, that no matter what size figure I'm given, it's 180 degrees for each triangle times n minus 2. So you just take the number of sides, subtract 2 from it, and then multiply by 180, and that will tell you the sum of all of the angles inside of a figure. So if we're looking at this figure on the left here, this is a 7-sided figure. It says that if we add up all 7 of our angles, it's 180 degrees times 7 minus 2 in parentheses. We're going to subtract first, then multiply. So that tells me that the interior angle sum of this figure, of any 7-sided figure, is 900 degrees. Now, you'll see this idea of a regular figure coming around, this regular n-gon. That just means that every angle inside of that figure is the exact same. Think of an equilateral triangle with bigger sides. So like a 4-sided regular figure is a square, and a 5-sided regular pentagon would have all 5 angles equal the same thing. In order to do that, we use this formula right here. It's the same 180 degrees times n minus 2. We're then going to divide by the number of sides. So in our pentagon here, if we do 180 times 5 minus 2, that's going to give me a value of 540 degrees. We're then going to divide that equally amongst 5 angles, and it gives us a value of 108 degrees. So I've got 2 examples here that I'm going to step you through, and this is really how the process works. They want to know the interior angle sum of a 17-gon. I actually do not know the name of that figure. But all you would do is 17 minus 2. You're going to multiply that by 180 degrees. So simple arithmetic to start out. 17 minus 2 is going to give me 180 times 15. And when we do 15 times 180, we end up with 2,700 degrees as our interior angle sum for that, which is a humongous amount of degrees. But it's a 17-sided figure, so that makes sense. Now, our second example is a little bit trickier. So they want us to find how many sides a figure has based on one angle measure. So we're going to end up using this formula up here. We're going to do 180 times n minus 2 divided by n. We don't know how many sides, so n will stay as is, and that's going to equal 172.8. What I'm going to do is I'm going to first multiply both sides by n. So I'm going to have 180 times n minus 2 equals 172.8 n. I'm then going to distribute this 180. So I've got 180n minus 360 equals 172.8 n. And then you have 2 options here. I'm going to save ourselves a step of algebra and just make everything negative, so it'll be a minus 180n. And so when I do that, I'm going to do 172.8 minus 180. I'm going to end up with 7.2n. And then if I divide both sides by negative 7.2, I end up with 50. So my figure here, in order for every angle to be 172.8 degrees, would equal 50 sides. So that's really as far as it goes with interior angle measures. We can find the sum total of the interior angle measures, and we can find a single angle. Now, if we want to take a look at exterior angles, we've got a little bit of an easier time here. So an exterior angle, if we remember, is just if we continued off of each side. So like those 8 angles that are labeled there are outside of the figure, and they're adjacent to all of the interior angles. Okay, so it's an extension of one of the sides. And if you look closely at the way that they've done all this algebra, I'll let you read it and discover it. No matter what, the exterior angle sums are always going to be 360 degrees. I don't know how it works out that way. There's a long proof, but in the long run, we end up with that every time. So if they say what's the sum of the exterior angle measures of a convex 17 gon, it's quick. It's 360 degrees. There's nothing really to do mathematically there. Anytime they ask what's the exterior sum, it's always going to be 360. So our final example is that we can use that 360 degrees to figure out an example like this. So here they told us that angles 1 and 3 were the same thing. And they told us that angle 1 was equal to 3x. And angle 2 was equal to 2x. And since 1 and 3 are the same, we know 3 is equal to 3x. Looking at what they've given us here, these two are right angles, so that tells me that this is 90 and this is 90 for both 4 and 5. So if all 5 of my exterior angles equal 360, I'm going to do 3x plus 2x plus 3x plus 90 plus 90. And that's going to allow me to solve for the value of x here. So combining everything together, I have 360 equals 8x plus 180. And subtracting 180 across, I have 180 equals 8x here. So it's just a little bit of quick arithmetic here to do 180 divided by 8. And so x is going to have a value of 22.5 here. So as we saw with interior angles, it was always 180 times n minus 2. And with exterior angle sums, it's always going to be 360 degrees. So it keeps it a little bit standardized, and you get very comfortable doing this over time. If you guys have any questions, make sure to bring them into class tomorrow, and I will see you then. Have a good night.